We're going to talk about cannabis and environmental impacts, kind of keep this theme going. Dr. Greta Wengert, 25 years of research experience. She is the executive director of the Integral Ecological Research Center up in Humboldt County. That's why we call it the IERC, because it is so much easier to pronounce. She's got a PhD in ecology. And since 2012, the specific focus that she's had is the environmental impacts on the illicit trespass marijuana growers on public lands, the surrounding habitats and wildlife. And folks, habitat and wildlife, that also includes humans that use these lands, all right? She is an NMI speaker. She is a research partner, and more importantly, she is a great person and a good friend. So Greta, I'm going to turn it over to you and sit back and let you educate us.
All right, thanks, Dale. And I also want to thank Paul and Amy for bearing with my technical difficulties up until literally the last 5 minutes. So thank you all for making this happen. I'm happy to present on my research today. Yeah, I'll be talking on the environmental impacts from illegal cannabis cultivation in California. I've talked on this quite a bit over the past few years. So some of this may be review for some of you, but I try to update all our numbers and our trends and add some new slides here and there. But I am also going to talk a bit about some new approaches to address an old problem at the end, which should be some new material for most folks. I would like to acknowledge all the cooperators and funders for a lot of the work I'm going to present today. There are many. These are some of the many agencies that have either worked with us, provided information, partnered with us on some of this research, or supported us through funding. So with that, I'll get into it. So why are there concerns about environmental impacts? Cultivation is legal, right? Well, the vast majority of what we see cultivated in California is unpermitted and illegal. All cultivation on public lands, which is primarily what I'll talk about today, but I will segue into some of the private land research we've done. Any cultivation on public lands or trespass cultivation on private lands is illegal. And of course, unpermitted cultivation on private lands is illegal as well. And we've heard a lot about that today. But who are the cultivators? Well, they could be your average American citizen. And I think that that's probably how it started out many, many decades ago here in the Emerald Triangle where I'm at, Humboldt County. But it has really evolved to encompass all kinds of players. And unfortunately, that includes international drug trafficking organizations, which aren't just specific to dealing marijuana and even some of the other drugs, but many of these organizations have a hand in firearm trades, human trafficking, and some other pretty awful crimes. So, you know, they're not just restricted to cannabis. But everyone in between, as we've heard about, you know, Hosty talked about some of the stuff that she's working in Siskiyou County and all throughout California. There's just all kinds of players in this game, unfortunately. So unpermitted means no regulation. And what does that really mean from the environmental standpoint? Well, it means that there are no limits on resource extraction, meaning folks can use as much water, soil as they want. They can contaminate things such as all water downstream of them, the soil and wildlife, and even humans as well. And so unfortunately, this can be a pervasive problem. So a little bit of background, this organization started in this research, I'd say around 2009, and it's because of this species that you see on the screen, which is called a fisher. We had, none of our research had to do with marijuana at all at that time, but we were studying this critter who unfortunately sort of coincides with the problem very significantly. It's a species that lives in the forest, only in the forest, and usually and typically in very remote forests away from people and away from agriculture. So we were studying this species looking at limits to their population. And the population we were studying, one of them was down near Yosemite National Park, where the species occurred in the forests and beautiful remote wilderness areas of Yosemite and Sierra National Forest. Well, we also tracked them till they died, and one of our goals was to figure out how they were dying. Well, we came across this fisher back in 2009 that turned out to have died from rodenticide poisoning. Of course, looking back, hindsight is 2020. At the time, we had absolutely no idea where these rodenticides could possibly be coming from. But through close collaboration and conversation with law enforcement agencies, what they had mentioned to us is, we think that the problem is really sourced from illegal cannabis cultivation on public lands and adjacent private lands. And so thus began an incredible collaboration and partnership with different law enforcement agencies over the years that allowed us to continue our work and identify and present the information that I will show you today, so that our team eventually looked something like this. Getting back onto the fisher work, since we were allowed to now investigate this issue in more detail, we were able to continue our fisher work looking at the extent of the problem and whether over the years it was getting better. Well, here's some stats from 2 papers we published that really show that rodenticide exposure to fishers really was not declining, and it was pretty significant, such that 85% of the fishers that we were looking at during necropsy, that's basically an autopsy for wildlife, were exposed to these anticoagulant rodenticides. Even after many of them were restricted with EPA restrictions in place. Most recently, up through January 2017, but we actually have data up through 2020 now, nearly 100% of the animals we look at are exposed to rodenticides. And we're pretty certain that these rodenticides, even though they are restricted, are continuing to be used at both private, unlicensed, and trespass cultivators on national forests and public lands where they occur. So this really inspired us to look more at the extent of the problem, both pesticide and otherwise, at these illegal cannabis sites. So what the goal of this project was really to look at different types of pesticides that were out at these sites, fertilizers, and try to document as much of the environmental risk as we possibly could. So our first goal was to look at, okay, what kind of pesticides are out there and in what quantities. And so what I'm about to show you are averages across the sites that we were looking at over the past decade. This, like I said earlier, most of our earlier work really focused on public land cultivation, but as the problem really shifted, I think Nate Arnold mentioned that 10 years ago it was a problem on public lands, but now it really has shifted to include primarily private lands and the environmental devastation that they're seeing. So some of our data stems from there as well. So of course, we see lots of fertilizers. On average, at your typical cannabis site, we see about 900 pounds of soluble fertilizers, and these are being used on areas of cultivation that probably only warrant maybe 10 pounds of that same fertilizer. So heavy amounts of fertilizers are being used, liquid fertilizers as well. Pesticides, which I'll talk about in more detail, on average 11 pounds of pesticides per cultivation site. As we start to look at more and more private land sites, this number is just increasing. And so hopefully the next time I present, I'll have some comparison data and show what we've been finding at the private sites over the years. Back to those anticoagulant rodenticides, here are the numbers that we see on average at each cultivation site that we investigate. And at this point, we're in the hundreds across California. So pretty high numbers. Again, I mentioned anticoagulant rodenticides. A lot of them have been restricted such that you need an applicator's license or commercial purposes for use. But that's not what we're seeing out there. We're seeing the second generation anticoagulant rodenticides being used by these growers without licenses. We have tried to track rodenticide use over the years, and I think this is an interesting and very telling graph of what has been going on. 2014 was the first year that we really tried to quantify use at the sites that we went to, and you could see significant amounts of rodenticides were being used at that time. Well, the end of 2014 was when the EPA started restricting the use of second-gen rodenticides, and we did see a resulting significant drop in their use at cannabis sites in 2015, with sort of some fluctuation over the years following. But interestingly, the last time we really tallied all of this in 2021, somehow growers were getting their hands on restricted rodenticides in quantities that we hadn't seen before, actually, even when they weren't being so heavily restricted. So we do see a little bit of positive impact from these restrictions from EPA, that their use has gone down, but there are these blips in the data that suggest, okay, there's still a source of these rodenticides that we're just unable to ascertain. I'll talk a little bit about carbofuran. This is probably one of the scariest, most toxic pesticides that we see out at the sites, both at trespass cannabis cultivation sites on public lands as well as on private lands. It is a carbamate that has been banned for all legal use in the United States, Canada, and the EU because of its toxicity to humans and wildlife. To give an example, just a quarter teaspoon of this can kill an African lion, and it does have a few different manufacturers. Sometimes some are manufactured in the United States, although I think that has been stopped in recent years, and manufacturers in Mexico. 99.99% of the bottles that we see are labeled in Spanish, and so they're getting here through our southern border. But because the United States used to produce it a while back, every once in a while we see an English label that probably dates back several decades. But again, they're commonly smuggled into the US by DTOs, and that has really prompted the EPA to try to buckle down and build some cases against this pesticide being smuggled, as well as some others. So unfortunately, it became, hopefully you can see the video, it became really significant to the world after in Africa, videos like this were emerging of African wildlife being poisoned by carbofuran. That's an example of an African lion that had been poisoned through poisoned meat. It was intentionally poisoned. But that is what really prompted some of the first world countries to ban this pesticide because it was so highly toxic. So we've been tracking this pesticide as well as other banned pesticides in the United States at cannabis sites since 2012. I'd say our really good data started in 2014. But this is what I'm showing here is not the amount of carbofuran being used, but the percentage of sites that we visit where they are using carbofuran or other banned pesticides. And you can see a huge increase over the past decade. Until about 2018, it really has leveled off, that anywhere from about 75% to 80% of the sites out there are using these highly, highly toxic pesticides. And, statistically speaking, I would say that, for the past 5 or 6 years, it's sort of leveled off, and it is just remaining at that very frequent level of use, unfortunately. Another graph just sort of showing what we see over the years. We definitely see over-the-counter pesticides being used. Just because they're over-the-counter and you can purchase them doesn't mean they're using them legally. So, they're not being used per manufacturer's instructions, which really are meant to try to protect people and the environment as much as possible. So we have seen an increase in over-the-counter pesticide use, and just sort of a continual use of these banned pesticides as well. So how are these pesticides used? And why is it important to the environment? So if they were just, maybe if they were in a greenhouse and using these pesticides just on the plants, maybe we wouldn't see the impacts we do. But unfortunately, they use them in a way that makes them very damaging to the environment and people. The plants are sprayed mostly with these pesticides. So sometimes, we'll go to a site and see plants that are speckled with white or pink fluid. And we know, okay, that's not good. That definitely doesn't look normal. And we probably shouldn't be touching these plants. And so sites like this have really prompted a huge increase in awareness among law enforcement and supporting agencies in how sites are eradicated, really, and how plants are removed. And I think that awareness really has paid off in decreasing the amount of exposures. Unfortunately, we see new techniques and applications all the time. So it's sort of just a cat and mouse game of making sure we have the correct PPE. Often these pesticides are applied directly to the stalk, or they could be applied to the soil. And so even the soil is contaminated. We know that a lot of them are systemic, which means that the pesticides are actually taken up through the cannabis plant, and their mode of action can operate that way. So even if it's just applied to the soil, it still ends up on the plant and is transpired through evapotranspiration of the plant. And so you may not even have to apply it to the plant itself, but we would still be able to detect that actual material on the plant when we test it. Some of the sites, unfortunately, they're using these very toxic pesticides to target nuisance wildlife, or what they consider nuisance wildlife. And so many times we'll see tuna cans where these, let's say, carbofuran or methimidofos are mixed with the meat and attracting wildlife to get poisoned and basically get rid of that problem. So carbofuran is not the only pesticide risk. So a few more that we've seen recently are things like methimidofos, which is an organophosphate, different class of chemical, but equally as toxic as carbofuran. This was in 2018, sort of one of the first few times that we'd seen it, where a deputy actually got exposed to this chemical. They'd never seen it before. And unfortunately, this is where, I just mentioned there's new tools and techniques that these growers are using that we sort of have to adapt to year after year. And this is one of those cases where no one had really seen this before. And unfortunately, it resulted in someone going to the ER. It's a systemic pesticide, just like carbofuran, which I just talked about. And we are definitely seeing its use on the rise in California. There's a few more. Hasti talked in depth about the Chinese fumigants that we're seeing in Siskiyou and other counties. This is just one example of the ones she was talking about. You can see again the wicks and the sawdust material that they use to turn this pesticide into a fumigant. We don't know as much about this and some of the other ones that are sort of just emerging that grows that Hasti talked about. And so we'll just have to adapt again, with new PPE and ways to evaluate the damage that these pesticides are causing. So we spent a lot of time documenting what's at these sites, which pesticides, what fertilizers, but then we wanted to take it a little further and identify, well, how significant is the contamination in the environment? Is it getting into the soil? Is it getting into water systems? Is it making it below the grows? And so we began a long process of environmental sampling, which includes soil, water sampling, looking at the cannabis plants themselves, and even looking at native vegetation to see if either native vegetation around the grows is contaminated through overspray, or potentially because they're systemic pesticides, are they being taken up through the native vegetation as well? So Over the years, we have sampled 402 sites throughout California. I would say about probably 90% are public land sites, about 10% private land. We definitely see some of the same trends there. But we've taken over 2,500 samples of those media that I just talked about. Our work really initiated in Northwestern California, which is where we're based, but we have made good efforts to spread throughout the state over the past few years so that we can get some good representation in Southern California, the Sierra Nevada, and even down in the Central Coast. And so this is what the distribution of our sample set looks like. On average, what we found is that about 16% of cannabis sites we can actually detect pesticides in the water, and that's pretty concerning, I think, to most people, especially since some of these grows are just above municipal water sources. About 60% of soil is contaminated, and I will give you the caveat that a lot of the sites that we had sampled, we sampled years after the last application. And so these could be sites that had pesticides at one time, and then we were unable to detect it. But as I'll show in a few moments, we also have been able to determine that these last in the soil a very long time. And about half of the sites we have visited, the actual cannabis plants are contaminated with some kind of pesticide. And I think that number has probably increased after the past couple of years of data that we've gotten. Every other site that law enforcement goes to eradicate, they have to consider there's a 50% chance that the plants they're intending to cut or remove somehow are contaminated with some kind of pesticide. We detected several, like I said, most of these are from public land grow sites, but what we have found over the past few years is that the private land data match this very well. So how long do these pesticides persist? We did a long-term study. I'll just put these up here so you could sort of peruse these graphics as I talk about them. We wanted to determine how long it took for all pesticide residues to get beyond or to degrade to the point where they're undetectable or not a risk anymore. And unfortunately, at a couple of the sites that we've looked at, even after year 4, and this is post-eradication, so it's actually 5 years post-erad, that we are still detecting things like carbofuran and diazinon, which is an organophosphate in the soil. And so these are persisting incredibly long times, which really means that they are likely using these pesticides in such huge concentrations, well past the manufacturer specs, that they just last much longer than the manufacturer indicates that they will take to degrade over time. One interesting result on the lower graphic, which is showing vegetation, and this is native vegetation we sampled at a few sites on the Plumas National Forest, where several years after eradication, a cannabis plant that had sort of regrown from a stalk that was cut years prior actually showed contamination with carbofuran. And so that is really just highlighting the systemic nature of these pesticides, that they remain in the soil, and the plants will just, whether it's a cannabis plant or native manzanita or what have you, it's going to just take up those pesticides if they're available and be contaminated themselves. Yeah, a little bit about water. So we published a paper a couple of years ago. Ivan Medell is the lead author on this study. He is one of our main IERC ecologists here, and he has a background in watershed restoration and water quality. I'm going to show you the graphic from the paper, but I'll explain what you're looking at. But first, what we did is we went downstream of these sites, and we put in, they're basically, we call them POSIS, but they're passive water monitors. So you leave them in the stream for about 20, 30, or 40 days. And all the water that washes down, any contaminant that passes through the filter will cling to that filter. And then we're able to look at it and evaluate it for pesticide contamination. What we found is on this graph, so basically the x-axis on the bottom represents, as you move farther right, that's the farther from the grow site that you get. And the y-axis, which is the one on the left, the higher up you go, it's the farther downstream. And so you can see that we detected both carbofuran and diazinon in water pretty far below grow sites, which is really, I think, alarming. Carbofuran, like I said, it's highly toxic. It's been banned. They're using it at the sites, and it's actually getting into the water system. The good news on this is that it isn't being detected at great distances below the grows, which means it's probably being diluted to a point where it's undetectable. And so there's good news and bad news on this, but it just really shows that especially with large water years and water events, hopefully these contaminants are being diluted to the point of not being as much of a risk to humans and wildlife. So switching gears a little bit, I just want to talk about water usage and how that cumulatively sort of adds up over time. This is one site that we went to on the Lassen National Forest several years ago. And here's some of the statistics of what we saw just from this one single grow site on our national forest. So estimated about 30 million gallons per year was being diverted. If we multiply that by the thousands of sites that are out there, you can sort of just calculate in your mind how significant of a water theft issue that is. If we look at what Humboldt County, they published some information a while ago through their cannabis ordinance draft saying that each plant uses about 6 gallons a day. We think that that's an underestimate. We have done some evaluations where we measure the actual diversion rate, not necessarily how much the plants are using, but the diversion rates. We think it's a lot higher than that. Our estimate is that it's about 9.5 gallons per plant per day that is being diverted. So think about the millions of plants that are eradicated each year. Now you're talking 9.5 million, or double that or triple that per day of water. I began this talking about the fisher being a species that is heavily impacted by this activity. They certainly are not the only species that's impacted. In fact, we try to make a concerted effort to look for dead wildlife at every site we go to. And we've taken a few statistics on that, which I'll show you, but I do want to sort of highlight the different species that we and our partners have detected dead at grow sites, usually from pesticide poisoning or contamination. But we're talking about bighorn sheep and rabbits and fishers and mountain lions and birds of prey. I think there's a photo of a golden eagle on a slide that I took out of this, but you name it, we have found it dead at grow sites. Huge trophy size bucks in the Plumas National Forest and other national forests in the wilderness. So it is a significant issue. Here are the stats we've collected. We have more numbers now. These are the last time I compiled it. This is what it looked like, but basically every other grow site we go to, we find dead animals, and usually on average at a site where we do find them, it's more than one. And so we think that, if they are taking the time to poison wildlife, they're usually doing it to get rid of pretty much everything that's out there. I'll start this video in just a second. I want to talk about it a little bit. This is a video that actually my grad student at Humboldt State University took. She was studying actually foxes at grow sites. But I think this really exemplifies that it is an issue, especially to fishers, which is the star of this, this video. Get that started. But it really just highlights that, you know, animals are curious. They are attracted to these sites, and they are definitely visiting them and investigating to the point that it could be pretty dangerous to them. This is a fertilizer bag. There's a pesticide bucket right next to it. But this was sort of the smoking gun. You know, are fishers and other wildlife attracted to these sites? Are they using them? How are they at risk from these pesticides? Well, that was pretty good evidence that that is definitely the case, that, you know, these animals that a lot of sensitive species too are attracted to and at major risk of contamination. A few other photo series I've got. This was a site in the Sierra Nevada where we found carbofuran at a site. We tried to mitigate it as best we could while we went to get a hazmat contractor to remove it. These are pesticides that you cannot legally transport to a disposal facility without a particular license. So you have to arrange for that ahead of time. In the meantime, this black bear came into the site, somehow got into the pesticides, and you can actually see in this photo how this bear basically got sprayed with what we think is carbofuran while it was investigating the site. And I think that this is probably an incredibly common occurrence, whether it's private land or public land sites where pesticides are used. Black bear happens to be probably the most common dead animal that we find at these sites. All of that, you know, it's all pretty awful, but at the same time, it's the trash that's left behind at these sites is absolutely incredible. I mean, the footprint of what they're using and is left behind is really significant. This is a trespass site on the Lassen National Forest, and the camp that they left all their sleeping bags and food and pesticides and what have you at the site. This is actually a private land cannabis dump site in Trinity County, another grow in Trinity County. And, you know, when you see this, it's not just the pesticides, but look at you can imagine the water pollution, the contamination of animals that are attracted to these sites, and obviously a public safety risk. This is an amazing photo in a sad way. Some of the grows that Hosty was referring to in Siskiyou County, well, this is one of them, and you could see just an environmental disaster and trash with the beautiful Mount Shasta in the background. And so, you know, I think this really contextualizes the importance of the environmental concerns at these sites in these very, you know, pristine, remote, or what should be remote, pristine habitats. Okay, so that's all sort of the doom and gloom. I'm just going to check my time here. And I do want to present some newer approaches, a couple older ones that we have embarked on with partners to try to address the problem, which is an ever evolving problem. But sort of looking at it from a 30,000 foot view, the scale of the problem across California. So how can we really tell how big this issue is? We certainly have you know, data that shows how frequent these sites are across California. But what can we do to really identify the areas of most risk? Well, starting in 2014, we began partnering with law enforcement, and were able to generate MOUs that allowed us to use law enforcement sensitive data on growth site locations. And ever since then, our data actually at the time dated back to 2004. Now we actually have data spanning back to the early 90s and then up through just recently. So, this recent eradication season. So we have lots and lots of data, probably about 4,000 to 5,000 locations of illegal cannabis sites throughout the West, not just California. With the modeling, we've really tried to focus in California, but it is an incredibly huge data set. We feel really lucky to have it and be able to share it with law enforcement for reconnaissance purposes, conservation purposes, as I'll talk about. So our initial approach was what we called MaxEnt modeling. And this is where we use growth site location data and landscape features that through conversations with law enforcement, we think growers are selecting their locations on. And we use that to model growth site risk. And I'll try to explain here what I mean. So you've got some geographic layers that you're looking at. Each little square represents a variable and the different factors of that variable. So let's say that the one at the top left could represent type of forest, and the different colors are different forests. And the one at the bottom left is maybe elevation. And so the purple is low elevation and the green is high elevation. Then you plot all the locations or all the little dots that you see, and you combine all those variables together and look at if there's any patterns in the different variables that those locations are occurring. So let's say for trespass cultivation, it seems like on average, growers are choosing mid-elevation, mid-slope, heavy forest, maybe close to water. And you really identify the environmental variables that those sites are associated with. Well, then you can project that across the landscape and find other areas that we maybe don't have data for, but that look really good for growing. And there's a lot of things we can do with this information. We can predict grow activity within sensitive species habitats, where we don't have any data and law enforcement doesn't have data, and we can overlay risk maps with habitats for these species. And so we took this approach initially. It's morphed in the past few years, which I'll talk about, but our initial map looked like this. So this is the modeling extent, is the colored portion of the map that you see here, where red is high likelihood of cultivation or illegal cultivation, and green is low likelihood. Well, then we took this layer and overlaid it with a few species that we were very interested in looking at. Okay, what's the risk to that species? And we chose Humboldt marten, which is up here in the northwestern California. It was just listed under Endangered Species Act. Pacific Fisher, which I've been talking about throughout the talk, it got listed down in the southern Sierra Nevada. And then, of course, northern spotted owl, that most of you have heard of, has sort of faced conservation issues over the past several decades. Well, when we overlaid that, what we saw was that a lot of the high quality habitat represented by these species was impacted by cultivation. So let's take the Fisher, for example. You're looking at the middle map. Any color you see is high quality habitat for Fisher, but if it's red, that means it's high quality habitat for Fisher that is hugely impacted by the risk of cultivation. And so you could see that for the Fisher, they sort of exist in a habitat that growers really like to grow in. And so thus we can see which species might be most affected by this activity. Here's some numbers, I'll just breeze through them. Most importantly, I think, is the Fisher habitat. Basically half of its best quality habitat is at high risk of cultivation. And you could see the same for the spotted owl. About almost half of the spotted owl habitat is also at high risk of cultivation. And interestingly, the Fisher and then the California spotted owl both recent listings under the Endangered Species Act, cannabis cultivation was actually cited in the listing as one of the significant threats to these species. So it's gaining some notoriety in terms of how it might be impacting the species that are so sensitive in California. We went on to do the same thing with California condors, both in the central part of their range where they've been for a while, and then in a reintroduction area up here on the North Coast. And you could see that sort of the Monterey area, Big Sur area, right along the coast, there's lots of grow site activity, and the condors are using those areas frequently. So again, it is a significant risk to the species. Now, what about private cultivation? So we have less data on private land cultivation, but we partnered with California Department of Fish and Wildlife and their cannabis program scientists to do the same thing on private land. And at the same time, we sort of partnered that with public land cultivation to get an overall risk map of illegal cultivation throughout California. So what private cultivation sort of looks like, and I think this is a neat depiction of its growth over the past decade, certainly since it was legalized. This is an area called Trinity Pines in Trinity County back in 2006. This is what it looks like on Google Earth. And as we move through the years, you can really see the impact that it might have on the environment. So each little polygon is a new grow site that has cropped up in 2012, and again in 2016, and finally in 2021. Out of all these sites, every little polygon is a grow site that has fragmented that landscape. Only 10% or less than 10% are in the licensing process, and even fewer are licensed. So most of this is illegal. Such that there was a paper that came out of Berkeley a few years ago comparing the fragmentation effects and habitat destruction effects of cannabis cultivation compared to timberland clear cuts. And what those authors and researchers identified is that private grows proportionally created greater edge habitat than timber clear cuts. And one of the most significant factors in the decline of some of the species I was just talking about, like spotted owl and fisher, is degradation of habitat, and most significantly, creation of edge habitat. Even researchers looking at habitat fragmentation have identified this issue as a real concern. All right, so back to the private land modeling. This is a paper that was led by Lindsay Rich out of CDFW that we were co-authors on. And what you're looking at here is that same modeling approach where we looked at, we took locations of grow sites and sort of projected the risk across the landscape. Left is the trespass cultivation on public lands, and the middle is the likelihood of unlicensed private cultivation. Of course, the Emerald Triangle, pretty significant, but you can also see in Siskiyou County, which is the northeastern part of that polygon, definitely a growing concern. Then you've got your licensed grows on the right-hand map, which sort of pale in comparison to the risk of illegal grows. This was the overall risk that we came up with, that risk of unlicensed private and public land cultivation is high and continues to be high in Humboldt, Mendocino, and Trinity counties. Siskiyou, it's emerging, and the Sierra Nevada foothills, definitely a big risk. We overlaid that with sensitive species again in California, and basically what this map is showing is anything that's sort of a dark reddish, grayish, dark color is the risk to sensitive species from both kinds of cultivation. So again, it sort of matched what we were showing earlier, really good fisher, spotted owl, martin, and other sensitive species habitat is definitely affected and at risk from this activity. So what can we do with this? Well, we can use this information to prioritize areas for species conservation. So perhaps in an area where there's a lot of risk, we heighten our eradication and reconnaissance efforts and culminate that with reclamation and remediation. But from the state perspective, perhaps we could consider that the cumulative impacts and have that be a factor in the permitting process. So maybe there's certain watersheds that are so impacted in sensitive species habitats that the number of licenses might be limited. And then land acquisition. So maybe there's areas that are not at risk that are important for species that we could prioritize for, let's say, conservation easements or other protected areas. Okay, and the last little bit I want to talk about is pretty exciting because we have partnered with NMI to do a project not just on predicting likelihood, but looking at new detection tools. And the idea is we want to use new methods to detect previously undetected cultivation sites, and then use that, go a little farther to use that information to employ what we call a mark recapture approach, which we do in wildlife a lot, where you use the ability to identify grow sites and how good your detectability is to get an estimate of how many sites law enforcement might be missing each year. This is an example of a site that was detected through this new tool that I'm going to talk about that was, you look on Google Earth, it's sort of plain as day, but the ability to detect it by traditional reconnaissance methods is going to be hard because, you pretty much got to fly every square inch of the landscape. But if you've got tools like the one I'm going to talk about, it might be a lot easier. So in short, it's called hyperspectral imaging. We work with a company called Aerospace. And what it does, it is a hyperspectral sensor on a fixed wing aircraft. It looks at not just the visual spectrum, but the entire spectrum above the visual spectrum of light. And what it's doing is it's looking for signatures that are emanating from what basically we have told them are grow site plastics. And so this last little graphic I just pulled up is, for example, a piece of tarp that we know are used regularly at grow sites, or a fertilizer bag, or an irrigation pipe. So this sensor, when flown on the aircraft, can actually detect a few square inches of that material, and just by way of the light spectrum that it is reflecting. So they actually approached us several years ago and we said, hey, this might work well. So we did a little pilot study in Tehama County. It showed some promise, but we then partnered with NMI a couple of years ago to expand that. And what we did is we did some overflights in the Sequoia National Forest and some BLM lands out in the southern Sierra Nevada, and looking for these materials. And what we found is that this is basically the data that Aerospace deals with. We don't interpret the data. They look at this and say, oh, that spectral signature is tarp material. And so then they just send us a map of coordinates where they have detected these materials that looks like this. So they might send us a KML file. Hey, these points have some kind of plastic that definitely matches grow site features. And then we can go out and verify or confirm that those sites. These particular points they sent us, here's what they resulted in when we actually went to do the ground truthing or the field reconnaissance. We found grow sites, and that's exactly what the goal was. This was one that they actually reported seeing a sleeping bag at, or material from a sleeping bag. And this is an old camp from a trespass grow site. Same thing here. The signature actually indicated tarp material. And we went and found a grow site camp with the tarp used as shelter. So it's incredibly effective. On an initiative where we got a grant or under an MOA to work with aerospace on this, and Forest Service matched some funds so that we could double the flight time. And what we were able to determine is that it's a really effective tool. So basically, here's what with the last set of flights, in 2022, it generated over 20 new grow sites previously undetected by law enforcement, and identified, and these numbers are actually, we have gotten better numbers since then. So I wrote 2 active sites in 2022, but it was actually 3. And just to remind you, this is just a small polygon in Sequoia National Forest. And then 5 this year in San Bernardino National Forest. So when we went to look at those signatures that aerospace sent us, 5 of those were actually active sites that were able to be eradicated that they never would have known about. So it's really effective. This is an example of the data that they'll send us, so you can see how many sites or potential sites it is detecting that are likely, not affiliated with anything anyone knows about. And so there's a lot of potential here to sort of expand our knowledge of what's out there. Last thing I want to talk about, we use this mark recapture approach from the aerospace data and other means to really get at how effective traditional methods, reconnaissance methods are from the law enforcement perspective, which is usually, flying in a helicopter, just spotting. And this is really, really preliminary because we have a lot more data. We need to crunch more numbers, but what it is suggesting, law enforcement probably at best has detected 50% of the sites that are out there. And so we estimate that it's anywhere maybe from 30 to 60% that law enforcement has detected in the past. Aerospace has added to that at least 20% on top of law enforcement that it is able to detect. So I feel like we're getting closer to the point where nearly all the sites that are actually out there should be detectable through this new method. And this is the last thing I wanted to show, is this is sort of where aerospace shines, is it may not be detecting the sites that are 10 or 12 years old because all that trash has been sort of scattered to the wind, but it's really good at detecting recent sites and almost perfect at detecting current year sites when they're active at the time of the flight. And so if you're thinking about from a conservation perspective, how good this technology is, you're getting the current sites as well as, the past 5 or 6 years of grow sites that may have been missed by law enforcement. It's finding those, and then we can take it the next step, eradicate the sites, and go with a final phase of what we're hoping to do is reclaim the sites so the growers don't come back. And so overall, aerospace far surpasses traditional recon methods for historical and current site detection in combination. And so the final thing I want to say is, this is a video of reclamation. That's sort of the goal of what we're trying to do. And from the law enforcement perspective, we reclaim a site, they won't come back. But from the conservation perspective, we reclaim a site, remove all the chemicals, and remove that risk to the environment, humans, and the folks that are working out there. I'll just let this video finish. This is one site that had massive amounts of carbofuran. Black bears were visiting. Got a huge group of watershed restoration folks together and were able to clean up this site. And over the past, 8 or 10 years, with this partnership, we've been able to tackle about 300 sites across California. So all this leads to a good effort and improvement of the environment and the impacts of cultivation. And with that, hopefully I have a little bit of time for questions. And again, I just do want to acknowledge all of the supporters' logos at the bottom of the page that all went into this presentation. Thanks.
Hey, outstanding presentation, Greta, as usual. Very informative. I do have a couple of comments, and then we do have a couple of questions. You know, when you start talking about trespass grows, you know, you guys have been dealing with this on the West Coast for decades. And I think, you know, if you look at this issue of trespass grows on public lands that now is moving into trespass grows on private lands, regardless of your stance on legalization, particularly on public lands, this should infuriate anybody with respect to the degradation that's occurring on our nation's public lands. Would you agree with that statement?
I would definitely agree with that.
Okay. And that being said, when you already addressed, and I think you've been very generous as a former operator on law enforcement's capacity to detect these grows. I disagree. I think it's a little, or the number's a little lower, but why is it important for our public lands partners to truly get an understanding of scope and scale of the problem here? Can you talk a little bit about that?
Yeah, I think that there's a lot of reasons that it's important for people to understand how big this problem is. First of all, public awareness. You know, I think that if the public thinks that there's just a handful of sites out there, they don't understand that it's an issue. There's safety issues around it, and that, you know, really it's going to take public concern and pressure to make sure that our agencies have the resources they need to deal with the problem. So that's one of them. But we also can't deal with the problem if we don't know what's out there. And so if we are detecting 10 grows a year and eradicating them and reclaiming them, if we fail to detect 40 more for every 10 we find, then the problem is never going to go away. The environmental impacts remain on the landscape, you know, well over, as I showed with the soil data, 5, 6, 7 years. The risk continues to be there. And from the public safety perspective, also, the growers just keep coming back year after year. Maybe they'll skip a year and come back to a grow that they didn't get busted at 2 years before. And so the tendency for the problem to continue will really just go on, you know, as long as this is an issue.
And you spoke about reclamation, remediation. Can you give us a little idea of the cost? And the second part of that question, what percentage of these sites that are reclaimed and remediated are actually revisited by growers?
Good question. So the cost to reclaim, and when I say reclaim, that's just moving the infrastructure, trash, and pesticides from the site. It's not, you know, removing the tendency for erosion. It's not replanting trees they cut. Just reclaiming costs anywhere from about 20 to 60,000 per site. And because that's labor, that's the hazardous materials contractor, that's the helicopter. I should mention that a lot of these sites are miles into the wilderness, or, you know, a mile off your nearest road. So it costs a lot to reclaim these sites. Second part of your question, Ed?
Yeah. If you reclaim these sites, remove the infrastructure, what percentage of it actually is reused by the cultivator?
Okay, so we've done a little bit of number crunching there. It seems like on average, if a site is not reclaimed, there's probably a 50 to 75% tendency for a grower to come back in year 2, 3, or 4 and reestablish, because all the infrastructure is there. If you do reclaim a site, less than 1% of the sites are re-inhabited. Okay.
Obviously expensive proposition, but again, our public lands partners don't know how much to ask if they really don't know how bad the problem is. We've got a question here, a couple actually. You talked about, you know, pesticides that are been introduced either on the plant topically or that are absorbed through the root system. Is there any agent, and this question actually asks it, can vinegar be utilized to remove pesticides from cannabis leaves or flowers? Or is there any other agent that you're aware of that can be used to remove these chemicals once they're introduced to the plant, the vegetation itself?
I actually don't know a good answer to that question. I have had some conversations with some folks that were promoting bioremediation, so actual like bacterial applications that degrade the pesticides. I hadn't heard of vinegar, although what I didn't talk about is an approach to eradicate plants safely. Vinegar does work; it kills them quickly. But as far as removing the pesticides, that's all I've heard of is the bioremediation approach, time and weather, basically. But unfortunately, when you're talking about, waiting for a rain event to wash it off the plants, it just ends up in the soil and the water.
Yeah.
So there are limited ways to deal with it once they're applied.
Wow. Thank you very much. Outstanding presentation. Again, always amazed, and we're happy at NMI to partner with IERC on the hyperspectral imaging project, and excited about phase 2 and see where that takes us. So again, Dr. Wengert, thank you so very much for your excellent presentation today.